Oh, hi, you sevens. Fancy meeting you guys here. It's been too long. It's been over a week since we've hung out together on YouTube. Uh, it's good to have you guys back. You've had a week with Miss Searle where you've been simplifying fractions and making equivalent fractions out of each other. And it's time to get on with some real stuff now. We've been doing fractions for almost 2 weeks now, and you've barely even started. You've barely even scratched the surface. We've got lots to do still. We're going to be adding and subtracting almost all week long. It's going to start somewhat straightforward today, and it's going to ramp up in difficulty pretty quickly during the week. So get ready to do some thinking and show some working out and be organized. No calculators. Let's get into it. So it's worth just revisiting what we've been doing so far this term. We've thrown a few topics at you regarding fractions, uh, and all these topics that we've done so far in fractions, they do have something in common, all right? So we've done mixed and improper fractions, turning one into the other, and you've spent a whole week looking at equivalent fractions and simplified fractions, and those ideas, they all have something in common. And what that is that every single fraction you've worked with so far, you haven't actually changed the size of a single fraction you've worked with. So essentially for 2 weeks, you've done literally nothing. You've made a fraction look different, right? You've dressed up a fraction in disguise, right? If I turn 1/3 here into 2/6 into 4/12, as you'll have seen by now, when I times the top and the bottom by the same numbers, like I've done here, this is just timesing the top and the bottom by 2. And look, this one from here to here is just doubling the top and the bottom again. These fractions are like literally the same, so it's kind of pointless, right? You've literally done nothing, right? You're just taking a fraction that is the same and just, I don't know, chopping a whole thing into more pieces, but still having the same amount. Same thing down here. This is what I showed you back a couple of weeks ago, that 2 wholes and 1/4 would be equivalent or the same as having 9/4. Same thing written differently. So what we've taught you so far is nothing. So given that we're almost a quarter of the way through this term of remote learning, it's probably time that we actually taught you how to do something with fractions, start changing the size of them or starting putting them together, giving you things that'll be useful in real life. Say when you do home ec next term, if you get to go into the home ec room, you might have to like put half a cup of this and a quarter of cup of that in together. You might need to know how many cups of ingredients you've actually got going on. So you'll have to add those fractions together. So adding and subtracting is a good place to start. Let's get into it. So what I think, and really it doesn't matter what I think, but let's roll with it. What I think for you guys to be good at adding and subtracting fractions from each other is you've just got to be able to like activate the logical part of your brain that asks you to add together things that are kind of the same as each other. So when I ask you to do things like go 1 plus 1, you'd all be shouting out right now in class, the answer is 2, right? 1 plus 1 is 2. And then if I extend that and I put billion after the word 1, well, if I ask what 1 billion plus 1 billion is, you'd say it's 2 billion, right? Since billions are the same things as each other. One banana plus another banana, well, you'd say it's 2 bananas, right? And then when we get to 1/4 plus 1/4, you should all be shouting out right now, 1/4 plus 1/4 would give me 2/4. In the same way that I have 2 bananas, 2 billions, and 1/4 plus 1/4 is 2/4. Okay, you might like this might seem obvious to you, and it might seem straightforward, but I'm harping on about this now because every year when we teach fractions, right, if 1/4 plus 1/4 equals 2/4, then so many students in our classes, right, you guys are out there, you know, some of these students would be you. So many of our students get a question like this. They go 1/4 plus 1/4, and then they write 2 on top of 8 as the answer, and it makes us sad and mad and feel bad, and it doesn't make us happy maths teachers, that's for sure, to see 1/4 plus 1/4 equal 2/8, because 2/8 and 1/4 are the same thing, right? 1/4 and 1/4 is 2/4 or a half. Okay, so we're going to really, really, really try and get away from adding the tops together and then adding the bottoms together, right? That's not what you're being asked to do. We'll show you what you need to do in a minute. Before we do actually show you what needs to be done today to get these questions right, here is just a nice open threat for all of you, okay? If I see anybody, or if any of our maths teachers at school see anybody in the school add the bottoms of two fractions together, we're going to find out, right? We will hear about this, and horrible things will come your way, okay? There is no topic or no part of fractions that will ever ask you to add the two numbers on the bottom. Okay? Do not ever in your life add the bottoms of two fractions together under any circumstances whatsoever. All right? If you add two denominators together, two bottoms of fractions together, you are in trouble. All right? And you know who I'm pointing at right now out there, right? You guys on the other end, you know I'm talking to you, right? This message is for you. So the actual concept behind adding fractions and subtracting fractions as well is pretty simple as long as our fractions have the same denominator. Okay, so as long as fractions have the same denominator, right, we're talking about the number on the bottom, then life is good, and adding or subtracting fractions is really easy. Okay, so as long as those fractions do have the same denominator, that means we're talking about the same type of fraction, right? Because both of these fractions are ninths, we're talking about the same kind of whole, right? In this case, we've got these squares, right? They're our wholes, and they've both been cut up into 9 pieces. And because they've both been cut up into 9 pieces, I can deal with those pieces really neatly and really easily. Okay, so when we're adding or subtracting, we're really just asking ourselves, how many of our type of fraction do we have? So in the same way that 2 bananas plus 4 bananas is 6 bananas, 2 ninths plus 4 ninths will always equal 6 ninths, all right? Do not add the bottom. We're not working with 18ths, we're only working with ninths. This number on the bottom tells me what kind of fraction I am dealing with. Because we're dealing with ninths, we can just ask the question, how many, right? So 2 of them plus 4 more of them makes 6 of them. Right, same thing for this, because we're dealing with sixths, all of our pieces are equal in size and the same as each other. They're all sixths, so 2 sixths and 3 sixths makes 5 sixths. And subtraction is going to work the same way. If I have 3/4 of a pizza left at home and I eat 1/4 of it, well, now I have 2/4, right? 3 take away 1 is 2. And you can see why it would be so silly to work with the numbers on the bottom. I'd have the number 0 over here if I did that. Do not touch the bottoms, only touch the tops. As long as our denominators are the same, you'll get the right answer. All right, so hopefully that instruction is sounding good to you, and this all seems nice and easy peasy lemon squeezy, because as long as our denominators are the same, and as I said in today's questions, they all are, life is good, life is easy, just add the top, right? Do it without thinking, right? Don't change anything on the bottom. This question is about eighths. Right now it's about eighths, right? It's just how many eighths are there, right? If I have 3/8 of something and I add 2/8 of that thing on to what I had, well, 3 plus 2 is just 5, right? I've got 5/8 and life's good. Now, that's going to help you get the first part of your questions right today, but then we are unfortunately going to ask you to go a step further. All that stuff we've taught you over the last week and a half, it actually wasn't for no reason. It's to make our fractions look simpler and nicer and better and easier to deal with. So we are going to ask you to go that step further today, and once you've done the easy part, which is the adding or subtracting, you'll have to maybe simplify. Okay, so if we look at this one, right now this question is about 20ths. And I just want to know how many I've got, right? I had 10 20ths, I take away 5 of them, that leaves me with 5. But then what we're going to ask you to do is look closely at your fraction and then ask yourself, can this fraction be simplified? Right? So again, what we're checking is a number that goes evenly into the top and the bottom. And unfortunately for you guys, there is a number that goes evenly into the top and the bottom. That number is 5. So to simplify this fraction, we just have to divide the top by 5 and the bottom by 5 as well. And that keeps our fraction equivalent, right? That makes sure our fraction isn't different in its size than before. It just looks nicer. So the top's going to be 1, because 5 divided by 5 is 1, and the bottom is 4, right? If you got 5 out of 20 on a test, that's a quarter, right? So I can write it as a quarter. What we're going to ask you to do on top of that is maybe convert some fractions from one appearance into another. What I mean by that is when I add them, right, I add these fifths together. 2 plus 4 is 6. I have 6 fifths. What you've been dealt, unfortunately, is an improper fraction, and they don't really look very nice. We have more than 5 fifths, which means we have more than one whole. Okay, so we're going to ask you to turn that into a mixed number and tell us how many wholes you've got, what you've got left over. So, harking back to a previous lesson, 5 goes into 6 one entire time, right? I have a whole thing in there, right? If my pizzas are cut into 5 pieces and I eat 6, then I've eaten a whole pizza. That was my first 5 pieces. And after I take away those 5 pieces that I turned into this whole, I have 1/5 left. All right, so we're putting a few things together. We've got one more example to go. Let's see if you can hack it. So in this last example we've got for you, there's a bit of overlap between all the ideas and concepts that we've taught you so far. You're going to have to do a few things to get to the final, best, most simplified answer. So we need to add these numbers together. There are some whole numbers, there's a fraction as well. Now there are a few ways to approach this. The way I'm going to show you today is to work with the wholes and the fractions separately for as long as you can. So we're just going to start by adding our whole numbers together, right? Our whole numbers are kind of separate from our fractions. We can say I've got 2 whole things here and 3 whole things there, that's 5. We're then going to put our fractional pieces together and then see what comes out of it. These fractions are both in quarters, so we're happy. We can just straight away smash the tops together and see how many quarters we've got. So 3 quarters and 5 quarters leaves us with 8. Okay, now we can approach this part in a couple of ways. We could try and simplify it as best we can, or we can just try and turn this improper fraction into a whole number. And for us, something's actually come our way. Something's come up conveniently for us. 4 goes into 8 evenly. 4 goes into 8 2 whole times, which actually means we've got 2 more wholes on top of the wholes that we already have. So I've got 5 wholes from this part of my number. And then the fractional component of my number gives me 2 more wholes. So this just becomes 7. Okay, so we started with a pretty straightforward idea, which is just add the tops of your fractions. And that's assuming that the bottoms are the same, right? In this case, right, we're dealing with eighths and 20ths and fifths and quarters. That's why we're just getting on with it, with the adding and the subtracting. But then we're going to build and build and build and incorporate all of the skills that you've picked up and smush them all together until all of your work starts to get not easy peasy lemon squeezy, but difficult, difficult lemon difficult. Okay, and in your next class, your second one for the week, it's only going to get worse. So good luck with today's questions and look forward to even more pain later in the week. See you later.